Hey guys, today we are taking notes on types of functions. You can find this in Google Classroom if you actually want to type on this sheet or print it out. If not, feel free to just do it on a piece of notebook paper. That is fine. But make sure you are writing the notes. I'm going to collect your notes at the end of the 9 weeks for a test grade. So make sure you have all of your notes for the whole semester, keep them together, keep them organized, and that could be a very easy 100 test grade. So if you need to pause this video real quick to go grab some paper or open up your other assignment, that is fine. Keep in mind with this flip video, you can pause this at any time. So if I'm going too fast and you're not writing that fast or drawing that fast, just pause the video and get what you need down and then keep going. You do not need to rush through this. You can take a break, do some of it, come back and do the rest. Doesn't matter as long as you get all this down. So going over the different types of functions, the first one we're going to talk about is linear. Linear looks like this if it's positive, and like this if it's negative. Linear also can have like a neutral one. This is called a constant. Go straight across. Notice it cannot be vertical. That's not a choice, but horizontal is fine. So things I need you to know about linear functions is the standard form is y equals ax plus b. The parent function is y equals x. You'll know from your vocabulary, parent just means a function in its simplest form. So that is the most simple linear function you can have. It is in the shape of a straight line. And it has a degree of 1. So you will also know from vocab that degree is your highest exponent. Exponent is the tiny little number, and so this one has a degree of 1. Anytime you don't see an exponent on a number, it's 1. All right, so that is linear. Next we have quadratic. This is the positive one. This is the negative one. What I want you to know about these, the standard form is y equals ax squared plus bx plus c. The parent function, which is the simplest, is y equals x squared. It is in the shape of a parabola. And it has a degree of 2. So your degree, like I said, is the exponent. And so right here you see 2. That is the highest exponent I see, degree of 2. Next we have a cubic. Remember, if I'm going too fast, just pause the video. The positive one looks like this. And the negative one looks like this. The standard form is y equals ax cubed plus bx squared plus cx plus d. And the parent function is just y equals x cubed. This one has a degree of 3. This is how you distinguish all of these guys. So the highest exponent I see is 3. Next we have a quartic function. Positive one looks like this, kind of in the shape of a W. And the negative one looks like this, kind of like an M. Things to know about quartic functions. The standard form is y equals ax to the 4th plus bx cubed plus cx squared plus dx plus e. Notice these are getting pretty long, but there is a pattern here. So if you notice this one, the exponents go 3, 2, 1, nothing. And the letters go A, B, C, D. This one does the same thing. Your exponents count down 4, 3, 2, 1, nothing. And alphabet goes A, B, C, D, E. So there's a pattern to it. The parent function is just y equals x to the 4th. And it has a degree of 4. So that is those 4. Next function is an absolute value function. The positive one is in the shape of a V, and the negative one kind of like a capital A. Things to know about absolute value. The parent function, is y equals absolute value x. So anytime you have x inside, these are called absolute value bars. That makes it an absolute value function. So x must be inside absolute value bars. If x is not inside those, it is not absolute value. It's something else. All right, then we have radical. A positive one looks like this, and a negative one looks like this. And so what I want you to know about radical, this is y equals square root x. This is the parent. Just a heads up, there are other ones. This can be cube root, fourth root, any root really. So whatever, doesn't matter. They're all radical functions. And just like absolute value, x must be inside of radical. Okay, this little check mark looking thing, you know it as a square root, is called a radical. But remember, if there's like a little 3 here, that's a cube root, or a 4, that's a fourth root. You can have multiple roots, so we call it a radical. Okay, next we have exponential. The standard form is y equals a times b to the x power. This one also has lots of parent functions, so you can have y equals 2 to the x, y equals 3 to the x, y equals 4 to the x, etc. Those are all parent functions, just like up here you could also have cube root, so I'll put that just so you can see it. You can have cube root, you can have fourth root. They're all parent functions. All right, for this one, oops, I didn't draw it, my bad. So a positive exponential looks like this. And a negative exponential looks like this. And what I need you to know about this one is x must be in the exponent. Okay, so as long as x is in the exponent, it's an exponential function. All right, and then we got rational. Rational functions look kind of funny because they have asymptotes. So this one looks like this. And this is not a positive and negative one. This is the function, just so you know. The equation for the parent is y equals 1 over x. Oh, I guess I should have put these were the parents. Let me put that here. Okay, so these are all your parent functions, but there's an infinite number of them. So for this one, your requirement is x must be in the denominator. For this, it doesn't matter what's in the numerator. Okay, you can have x in the numerator and x in the denominator. It won't matter. It's still going to be rational. If there's an x anywhere in the denominator, no matter what else is here, it's rational. All right, 3 more. We're done. Next is piecewise. Something you know about piecewise, it is broken into pieces. So it may look like this. Mind you, this could be anything, like literally anything in the world. So I'm just going to make one up. Okay, yours don't even have to look exactly like mine. Notice it's not one continuous line like we've been doing. This is broken up. I got a piece here, I got a piece here, got another piece here. So an example of this, just so you can see what one looks like. So you'll have f of x equals this bracket, and you're going to have a bunch of equations in here. So you may have like 3x plus 1 if x is less than 1, and you may have like 5 if x is greater than or equal to 1, something like that. So your equation is also broken into pieces. So these are very easy to recognize. Next we have trig. Your basic trig functions are y equals sine x, y equals cosine x, and y equals tangent x. These are all your parent functions. These are just a continuous wave. I'll do my best to draw one. So notice it just bumps up and down forever, like this. Okay, tangent does look different, but we don't graph tangent in this class, so I'm not worried about it. But sine and cosine look like this. It is just a continuous wave. It's always the same height, always the same at the bottom. They're supposed to be identical. I just hand drew it, so they're a little off. An example of one you might see would be like y equals 4 sine of 3x, something like that. And then the last thing I need you to know are the ones that are not functions, so you can recognize them when you see them. So an example of something that's not a function would be a circle, a vertical line, a sideways parabola, or any kind of sideways squiggle, really. Okay, all of these are not functions because they do not pass the vertical line test. The vertical line test says if I draw a vertical line anywhere on this function, doesn't matter where, it should only hit at 1 point. Well, this is going to hit twice, this is going to hit twice, this is going to hit 1, 2, 3, 4, 5, 6 times. A vertical line hits infinitely. It just keeps hitting the same line. So all of these are not a function. So if you can draw a vertical line through it and you hit that function more than once, it is not a function. All right, so these are all the functions we are going to cover in this class. So I went ahead and went over those. There are some problems on the back. We're going to do these together, so don't feel like you need to go ahead and do these. Just make sure you have all the notes written down, and I will see you guys later.